Howdy, how are you? I hope you are doing well. Hope you're having a good day. I am the Amateur Logician from amateurlogician.com. We're going to consider some vocabulary as it pertains to mathematical theorems and proofs. As we, for example, conclude the Suppies and Hill textbook, First Course of Mathematical Logic, we're going to deal with such things as axioms, corollaries, lemmas, theorems. So let's define some terms. So first off, what is a mathematical proof? And what are some of the different types of mathematical proofs out there? Well, mathematical proof is an argument. And a good argument is a valid argument. That is, it follows the rules of logic and is going to demonstrate some conclusion as being the case, as following from certain premises. Now we have, for example, direct proofs. Those are of the form if P, then Q. So if P is the case, then Q is the case. P is the case, therefore Q is the case. We have a modus ponens inference. We have contrapositive proofs. In this case, instead of proving if P then Q, so to speak, we prove if not Q, then not P. We flip the antecedent and consequent and negate both. We have existence and uniqueness proofs. For example, is there always a number in between two real numbers? Does there exist such a number? We have if and only if proofs. These are biconditional, so P if and only if Q. Additionally, we have proofs by contradiction. And we've done several on this YouTube channel. Moreover, we have proofs by induction. So these are the standard tools that mathematicians use. Direct proofs, contrapositive proofs, existence and uniqueness proofs, if and only if proofs, proofs by contradiction, proofs by induction. But what is a theorem? Now, what if we prove some important proposition? Well, if it's important enough, we will call it a theorem. You have such things as the fundamental theorem of arithmetic or the fundamental theorem of algebra. We also have just propositions, and the important propositions are the true propositions. If we have a true mathematical statement and it's not important enough, so to speak, to be a theorem, we'll just call it a proposition. We also have such things as lemmas or a lemma, and that is used in constructing a proof. So a proof may be very, very long, so you subdivide it and you have subproofs within the larger proof. And we say, well, this subproof we'll call a lemma. And once you have a theorem, oftentimes you can derive immediately various consequences, various logical consequences. You have a corollary, which follow from a given theorem. We also have axioms in mathematics. An axiom is just an elementary truth that is just assumed without evidence and doesn't need proof. For example, with elementary arithmetic, we just take it as an axiom that the commutative principle holds, that the distributive law holds, and so forth. And they cannot be justified with even more basic laws, so they're starting axioms. So this is an introduction to mathematical theorems and proofs. I'm the Amateur Logician from amateurlogician.com. Thanks for watching this video. Good luck to you and be well.